Alright guys, welcome to part 4 of the Raspberry Pi car tutorial. In this part of the video, we are going to be going over the GPIO pins. Now, as you can see, I've printed out a little piece of paper that helps us label each one of these pins. This can get a little bit overwhelming, but don't worry, we're only going to focus on 4 colors. We're going to focus on the red 5 volts, the yellow 3.3 volts, the black grounds, and then the green GPIOs. Those are the only ones that we're going to worry about for now. So let's get this Pi plugged in and let me show you guys a few things. Alright, so now we have power to our Pi. And I want to keep this close just so you guys can see exactly where I'm doing this. Here we have a small LED light bulb. Now, the way we can turn on this light bulb, or at least one of the ways we can turn on this light bulb, is to take 2 female-to-female jumper cables. You want to put your ground onto the shorter leg. See how there's different lengths of legs? So your ground is going to be the shorter leg. I always use blue for ground. And then your power is going to be the longer leg. So now we've got this wired up. And how can we add power to this light? Well, one way we can do it is we can hook up our blue wire to this ground pin, and then here, let me hold this up, hopefully you can see all this, and then let's just attach this power pin to our 3.3 volt, and see, we've got power. Boom. We could also put it into the 5 volt. Now this might pop the light. You can see that it's definitely growing. See, it's almost like a yellow color now. And if we left that there for too long, it would burn out. So that's a 3.3 volt. That's a 5 volt. If you feel it, it's getting pretty hot. So yeah, it's not great to but these are very cheap LEDs, so it's not a whole lot that we need to worry about. Usually you'd have some resistors in here, but let's not get into any of that yet. I just want to show you how power flows through the system. Okay, so we understand our 3.3 volt and our 5 volt pins and our ground. Those are pretty simple. They're basically self-explanatory. But where we're going to be doing all of our programming is in these green pins that are called GPIO pins. And I'll be able to show you as we type commands how we can get the lights to turn on and off using these GPIO pins in Python. Alright, let's get started. So as you can see, I've hooked up my ground to a ground lead and then my power to GPIO pin number 21. Okay, so let's open up the terminal and let's turn this light on using these GPIO pins. Okay, so we SSH into our Pi, type in our password. Let's go into our Raspberry car directory and let's make a new file called greenlight.py. And then what we want to do is we need to import some packages in order to get the GPIO function to work. So we're going to import rp capital and then lowercase I dot GPIO as GPIO. We're going to import time. And that's all that we need to import. So now let's go ahead and set up our GPIO pins. First thing, we need to do GPIO.setMode, GPIO.BCM, GPIO.setup. Oh, one thing I forgot. I always like defining my GPIO pins. So I'm going to put green equals 21. This is useful for if we ever switch out the GPIO pins of the green light. Instead of going back through the code and changing all of the individual numbers, we could just change the variable for green to say 18 or whatever. So that's useful. Always set up variables. So now GPIO set up green, which is the equivalent of saying 21, GPIO.out, which means it's going to be an output. We're going to be giving an output voltage instead of taking in information. So now that it's set up, we do GPIO.output green 1, which is equal to true. 0 is equal to false. So that'll turn our light on. Then we're going to go time.sleep 1 second. In the time.sleep function, the number that you pass is calculated in seconds. Then we're going to go GPIO.output green 0. So the light will turn on, wait 1 second, then turn off. So it should stay on for 1 second. And then the last thing we need to put is GPIO.cleanup. And that's it. Control X, press Y to save, enter. And now instead of nano green light, we are going to run Python green light. And pay attention in the top right of the screen, you should see that light turn on for 1 second and then turn off. One more time, turn on for 1 second and turn off. And that's it. That's how you get a pin to do an output. Next, we're going to look at something called pulse width modulation. And this is going to be the more important part of our GPIO output pins for controlling our car. So let's get into that. Okay, so what is pulse width modulation? Well, it's basically a combination of two pretty simple concepts. What we have here is frequency. It's measured in hertz. Basically, if we wanted to send out 1 hertz signal, it would be 1 pulse every second. 5 hertz would be 5 pulses every second. Now, I'm going to show you guys. I made a couple demo files on my Raspberry Pi, so let me just show you an example of frequency. If you look up in the top right corner, you should see these lights are pulsing. This one over here is pulsing once every second, so that's 1 hertz. This one's pulsing 2 times every second. And you can't tell that this one's pulsing because of the frame rate of my camera, but you might be able to tell that it's a bit more dull than the other lights. This one is blinking at 30 hertz, so it's blinking at, you would be able to see it with the naked eye, but not pick up through the camera. Okay, that should make sense. Now, there's another factor that comes into pulse width modulation, and that's something called duty cycle. So whenever we have a certain frequency, we can also tell our device to be on or off for a certain percentage of time. Whatever your duty cycle is, it's measured in a percentage, and that percentage is going to be the percent of time that the light is on versus off. So let me show you an example of this. Our duty cycle, if you notice, the lights all blink at 1 hertz, but this light is only on for 10% of the time, this light is on 50% of the time, and this light is on 10% of the time, or sorry, 90% of the time. So with the combination of frequency and duty cycle, we can make all sorts of different inputs to our devices. Usually, we use a certain frequency that a device will be able to measure and then pass a duty cycle for its relative power. So if we wanted our car to push the motor at 10% speed, we would use a duty cycle of 10 over here. But if we wanted to give it 90% power, we would use a duty cycle of 90. I hope that makes sense. I'm about to jump into the code, but I wanted to give you guys a visual representation of what was going on before I did that. All right, let's get into the code. All right, so I'm just going to walk you guys through these 2 demo scripts that I created and just showed you guys. So let's start with the frequency script. Oh, whoops, I'm running it. Let's nano into it. Okay, so I'm just going to go through this line by line and explain to you guys what's going on. Just like before, we import our GPIO in time. This time I had 3 lights, so always a good practice. Set them up as variables. Same thing with the set mode, BCM, and with the setup. All of these are going to be set up to GPIO.out. Now what's different is now we're going to enter them as a new variable. We're going to use this GPIO.pwm function. So our 3 lights are going to be, PWM 1, 2, and 3, and it's going to be corresponding red 1, 2, and 3. Now this number that gets passed in to the GPIO.pwm function is going to be the frequency in hertz. So this is going to be that first one that we saw, which is going to be this first light blinking once every second, 2 times every second, and 30 times every second respectively. Next, what we do is we start our PWM. So this is starting the pulse width modulation.
and the number that you pass is going to be the duty cycle. Don't worry about the different values inside of the duty cycle. I only did that to make it more visually appealing. We'll go over how duty cycle works in the duty cycle demo script. Next thing we have is this try while loop. So this is something that you guys can use if you want to basically not really pass a time, but you just want to have this function keep running until you exit out of it. You can do try. And so another thing to notice for anybody who's not used to Python, it is a white space language. So this indentation here is needed. You have to do try with a little colon mark like that, and then indent, and then do your while, true, indent again, and then I use the pass function. So this is saying, while all this stuff is going on, just keep passing. Except, so this is going to be on the same line as the try, except for a keyboard interrupt. So that would be Control-C is your keyboard interrupt, and then the script would keep running. It would turn off all of these pulse width modulations, and it would clean up the GPIOs. Okay, seems simple enough, right? Let's move into the duty cycle. Okay, so as you can see, it's the same as before. The only difference I have here is with my pulse width modulation, I set them all to a 1 Hertz frequency. So all of these are going to blink one time every second. But the difference is we have the duty cycle that's a bigger variable now. So now we have the duty cycle set up as 10% on our first light, 50% on our second light, and 90% on our third light. We use the same try while loop with the except keyboard interrupt, and it's essentially the same. So if you guys understand this, that's a great sign, because this is all that we need to control our H-bridge. And in the next video, we are actually going to be hooking up our Raspberry Pi to the H-bridge and wiring some motors together to see if we can get them to turn different directions and go at different speeds. It'll be fun. Hope to see you guys then.